Okay, students, hope all of you can hear me properly. And we were discussing about converting ER model into a database structure. Then we mentioned that very important. This is because of while you are deleting and updating table, or actually a record of a table, so you should be very careful, right? So, so, so you can do two things. So one thing is restricting the delete if it is affecting to other records of other tables, right? If it is not affecting, no problem. We can allow that delete. Okay, then that is called as cascade delete. And here, and we mentioned that the way that so scenarios related to adding painters to tables and making changes of tables related to primary key. And we mentioned some, so the cascade means what? Allowing to do, make the changes related to what? The given one here, this one related to update. Then we mention some examples, right? So this example, we mentioned that what are the things which are allowing here on update cascade, on delete cascade, and this foreign key can't be null, right? In other table. So primary keys, then class code. So here the in enroll table, right? So we can understand record. So here then in enroll table, so there are these are foreign keys, right? Then that foreign key values should be there. So normally primary keys of other tables should be inserted here. The student number, class code, got that. So if you are what? So delete. So that should be restricted because of why? There are it is actually a foreign key. So the records can't be deleted because of other tables are containing related information then. So even after also it needed to delete the class in this example, so must transfer all the data before deleting, right? Otherwise, okay, just after deleting data of a record, then other records also definitely affected, right? So by transferring data, so if we take action of deletion, that would be happen. So another thing is also if you make an object, changes also affected to what? Other tables too. Got that? So enroll table, then student number, then foreign key again. Then here, this is related to information regarding actually a enroll table. So the hope you can understand why we can't delete record of student, right? And why we can't. So then we should careful updating data. Then next example. So both sides are optional. What would be the thing defined by this business rule? So here you can see both sides are optional. Again, same like that way, foreign keys and primary keys are placed like same way, then how about this is behaving? So this is a option. These are optional, right? Then many to many, you know that this can be represented as this way by using composite entity. And then this is the explanation for it. So if the relationship is optional, a class can exist even if contains no students, right? Then this is optional. Look at the difference. So on delete can cascade. Cut that. The previous one is here. Again, also on delete what? Restrict. Because of this is not optional. These are mandatory. Got that. So that's the problem. Then restrict on delete, restrict. Here, deletions are allowed at here because of relationship is optional, right? If the relationship is optional, so deletions are possible. But that means what? Even if contains no students, no problem. So you can understand the differences. So due to this optional scenario, so when due to the both sides are optional, right? Here we understand the both sides are optional. Then these clauses are can be displayed like this way, and these settings can be set like this way. Then the next example. Take some time and understand these things. Okay. I will provide 1-2 minutes for understand these things. So would be important for understanding these things. The next example. So you can see here only one side is optional and other side seems like mandatory. Then you can, but if this is many-to-many relationship, look at this one and here. So we know that this optional notation should be placed at here when you are showing the relationship using composite entity. Then so enroll table operational side. Look at this one. Okay, foreign key should be not null. So foreign key should be not null here. Student number can't be not null. And student and class here we are discussing about. Yes, student number can't be null. After that, so delete cascade. So deleting the possible here because of student is optional to the class. Even without student records are there, okay, no problem. So deletion of student on may be accompanied by the deletion of student from classes. Hope you can understand these concepts. So the next one. Okay, then here. Then class code and this one also. Next one, look at this one. So here. So we don't want to delete a student from class. That is the only class the student is enrolled in. So that's why we have mentioned here on delete restrict. Okay, then other one is okay on update cascade. Look at this one. So here this is about a class code foreign key. Then here. We can't, we don't need to want to delete a student from a class if that is the only class student is enrolled in. So that means why? One student must be enrolled in at least one class, right? So must be enrolled at least one class. So if he is student, right, already registered, okay, we are not talking about that optional case, but when he is registered for classes, okay, then at least what one class he must registered with. So that's why on delete restrictions mentioned here. Got that? So the next one. So one-to-many, both sides are mandatory. Here, one-to-many relationship, and both sides are mandatory. No optional notations are here. And so this is the way that then you can see here primary key of department table and primary key of professor table. So these things, the foreign key can't be null. Here you can see that department code lies as a foreign key here, right, in professor's table. So that is the way that relationship has been built in between professor and the department. Then So these things we don't want to delete professor if department is deleted. Got that? So look at this one. So department, if department record is getting department 1, 2, 3, think that if someone is deleting department 1, so that professor data no need to be deleted, right? So that's why it is mentioned here as on delete restrict. So update delete cascade. Okay, hope you can understand. So next one is one to many. Both sides are optional case, right? One to many here, not many to many. Previous one was many to many. There were optional annotations. Here you can see so students 0 maybe or multiple students there. Then room there may be 0 or 1 according to this segment, right? After that, so this explanation, okay, read and understand, then foreign keys and student table. Then here, look at this one, room and building code here. And student table, you can see room code has been inserted as the foreign key for building the relationship in between student and room tables. Got that? So relationship means what? A room, then advisors to student, right? Then so this is the way. So if room is deleted, room records, room 1, room 2, room 3. So if room 1 deleted, what? Then student cannot remain in that room and will be affected. Yeah. Then normally, so one room, then there may be multiple students allocated to that. Got that? Then so have no room null until he reassigned to another room. Got that? Then if it is deleted, what? Then that becomes null, right? Then this student table room code becomes null here. If it is deleted, relevant room. Got that? Restrict, maybe use alert user to reassign user to student to another room. Got that? Okay, on delete. So set null or restrict. Yes, so restrict is most possible thing on delete restrict because of due to the mentioned reason. Hope you can understand these things. So on delete cascade, hope you can understand that also. Then other one is then only one side is optional here, one to many. Read these contents. Now you know what is foreign key and what is the relationship, what side optional. So what should be restrict when it is deleting, due to what, why. So that kind of things you should be able to understand by looking at this kind of example. So here also it's the same kind of procedures and things have been applied. So one-to-many relationship, professor advises student, and we mention, we explain these things, right? So you know that we want to delete student if professor is deleted. Yes, then that's why on delete has been restricted here. Got that? Yeah, the professor number, then professor number mentioned here as the foreign key. What would be the thing? If professor delete means what? Professor number related, that means a primary key delete when deleting. Then student record also getting deleted due to this foreign key. Got that? We should avoid that. The way that we should avoiding is by placing this clause in database. Got that? So when you are implementing databases, okay, you will practically understand where these codes should be placed and when. And at this stage, as a theory, okay, you should be able to understand these basic facts, right? Next case. So one-to-many. So one side optional and many side mandatory. And hope you can understand this relationship. Painting is in gallery. Gallery is optional. May not be gallery records. Got that? So, but one painting. Okay, then the maximum gallery count is 1 if it is displaying in gallery. Got that? So minimum paintings can be 1 and multiple number of paintings can be multiple values. Got that? That relationship can be displayed here. Hope all of you can understand again. And so hope you can understand what is the foreign key here, right? Painting number and gallery numbers are primary keys. So gallery number has been placed as the foreign key here in painting table. Got that? Then, so foreign operations on painting site, right? When it is making an operations in painting site, then you can see that gallery number is the foreign key. Got that? Then due to this optional scenario, then so these things here we do not want to delete paintings if we delete the gallery. The gallery number in painting must be set null. Got that? For an example here, when you are deleting some specific gallery, so gallery number 1, so that one also, that record deleting from this gallery table, but and some specific record in painting, so this gallery number record become the gallery number cell displaying it as null. Got that? Then if needed, you can restrict that. Then when it is trying to delete some record of gallery, then it is restricting user to delete that specific record due to what? This painting table also due to the affecting of painting table. Hope all of you can understand. And the update cascade, no problem. Then by keeping the same foreign key, you can the user can update these things. Allowing updates are so cascade means what? Allowing. Okay, then here you can understand these terms allowing and restricting. Got that? Why these things are performing? Why these things? Okay, I will explain that later as a summary of these for this presentation. And next one, so both sides mandatory one-to-one case, and one-to-one both side mandatory. So one professor, so there should be one room minimum and maximum also one. So professor count also a minimum one, maximum also one-to-one, exact one-to-one relationship here. And foreign key, what is the foreign key? And foreign key is room code here in professor's table, right? And foreign key is room code in professor's table, and it can't be null. Here, this is a mandatory relationship. Got that? And if okay, then if we delete room, what would be the thing happen, right? So we do not want to delete room. If assigned professor also assigned to professor, got that? Otherwise, the professor's data also getting deleted. So, right? Then if it is needed to delete, then we have to move that all professors' data to a different table or different room assigned. Right? Then only you can remove the some specific rooms. Got that from table. So that's why we are using these clauses here. Then case 9, both sides one-to-one and both sides are optional. Optional means no problem, right? Then after deleting also, Okay, we were discussing about these things, and here then both side optional case, right? Then so professor does not necessarily operate personal computer and no PC is necessary. Then this one, and if professor getting deleted, professor number also set null to PC entity. Got that? So professor, you know the professor ID thing the record, and if professor one first professor deleted, what would be the thing would be happens? The professor number can be kept as null. Why? What is the reason? Okay, we can keep it as null. Why? These things are optional. Got that? So now you can understand the uh, possibilities and impossible things you can perform while you are mainly while you are deleting records in databases. So updating parts are normally allowed because of that would not be affect. So due to then foreign keys are not getting null due to updation procedures. Got that? Updation actions. But we should then user should be careful when he is performing deletion actions or make deletions. So that's why it is some restriction clauses are there. There were. Then after that final one, then one to one, then one side, only one side is optional, professor. Then that can be displayed as this way. And for one professor, then it must have a room, maximum also room. Then here, like that previous example, room code functions as work as foreign key here. Then this is the explanation for that part. So foreign key operational entity, foreign key room code, we know that. Then you don't want to delete room if it is assigned to professor. Then first reassign the professor to a new room. That means you can what? How you can assign to a new room? Then you can update that, right? Update and remove the relationship that updating by updating records. Then you can change the environment. Then you can delete the current room. Then that would be not affected to other records. Got that? So after that, mandatory part, the room is mandatory to the processor. After that, then room might be empty. If a professor assigned to particular room deleted, the room will also vacant set null. Got that? So that's why this has mentioned as on delete set null. Got that? Okay, there is another one. So weekend related one. So this is very easy to understand because of you already have idea about what is weak entity. An employee has a dependent that is optional because of it is depending on the employee's existence, right? That cardinalities can be displayed as this way, and 0 to 1, 0 and 1, and here 1 and 1 employee. So then employee table you can see here. So no foreign keys, right? But independence table, you can see one foreign key. And if it is deleting, then if employee is deleted, employees dependent also get deleted. Okay. So no problem. So delete cascade is can be set as on. Got that? Then after that, updating no problem. Right? Hope you can understand this example properly.
After that, next example, multi-value attributes. Look at this one, and multi-value attributes, one can have multiple colors. So color is maybe optional. So these are the examples. Now you can understand these things, I think, properly, and after that you can revise these things. Then we can go to our next presentation. So mapping ER diagrams to relational schema. So next important part for exams also. So let's read these things and understand these concepts. So next very important part this is, right? And here mapping ER diagrams to relational schema. Okay, now we know about ER diagrams, and after that we are going to learn about relational schema. Relational schemas also we know we have some idea about relational schema. Here we are going to learn about when we have a ER diagram, how to map relational schema properly, right? So they are the things we have to go through here, right? Then mapping regular entities means strong entities, the normal entities. We know that others are weak entities, and so same. So here's the name, same name given, and here simple attribute of the entity type becomes an attribute of relational schema. The identifier becomes primary key of corresponding label. So what that has been explained there. Then here customer entity type AR diagram. Then here customers entity, customer name, customer address, postal code. So this was the entity, right? In the ER diagram. Can you remember then ER diagram? Customer had what? A customer ID as an attribute, and customer name, customer address, and postal code. So very easy to understand here. Then when you are building the table, right? Table, hope you can remember. So if we are building built-in table, so if we are entering records into this table, right? Then you can see here, then this is the way that a relation can be built, right? So we know that primary key should be displayed as this way. Composite attribute, and so normal simple entity that is having a simple attributes are displaying in this way when you are converting, right? Then here we are discussing about how to drawing the relational schema, right? Schemas, and here, so this is one step you have to go through in general context, right? When you are converting a ER diagram into relational schema. Okay, finally we will build the relational schema, okay, by understanding these essential steps, right? Then when there are composite attributes, now you should understand, you should know about composite attributes, right? Composite, what is composite attribute means? So one attribute have further, when one attribute can be further divided into more attributes, you can see that there is composite attribute, right? Then when you showing the relation of that composite things, that means when you are displaying in a table, so that is displaying in this way, all the composite, then mean customer address can be break into 3 sections, street, city, and address, and that can be displayed like this way. So composite attributes are can be displayed like this way, right? Multi-value attributes. Next one. Okay, hope you know about this concept, and after that we can study about relations. Here we are studying about relational schema. Before relational schema, okay, we just learn to know about a small relation sections, how we can prepare according to different situations, right? So in this situation, in this example, when there is multi-value attributes, okay, then how we can display relevant relation regarding to multi-value attributes. Okay, first read these things. After that, we will display the way that it can be displayed. Okay, then there is multi-value attributes. We can display that in this way, right? So previously, previous example, so employee can have multiple skills, right? So this is the so employee ID, employee name, and employee can have when employee can have so multiple skills, and you should be careful that kind of attributes. Then when you are mapping a relational schema, you have to take that, consider that multi-value attribute as a new relation, right? employee skill, then you have to give a proper name for that multi-value attribute yourself. And after that, you have to mention that previously, then this primary key here as the foreign key, then you can make the relationship, right? Then skill should, then employee skill table, then skill also mentioned as a key here, and that is the way you should display relations there. So this is the explanation for that section, right? Hope you can understand these things. Okay, the next one is mapping weak entities. So now we know about weak entities. And when there is weak entities, what are the things you have to consider while you are mapping weak entities in relational schemas? So these are the instructions which are given. You should, when you are following, when you are mapping weak entities, right? So this is the ER diagram relation. Okay, don't worry about this notation. This is a what? This is a relationship, and here many, you can say it has many and many dependents for one employee, maybe this kind of example. So you can see here employee ID and employee name have been inserted there, and here after that in dependent name, dependent first name, middle name, last name, and date of birth and gender as attributes. Okay, these two tables can be seen in this way, but when you are mapping them in a relational schema, you have to display like this way, right? So dependent, these things. So, and employee ID working as like foreign key, and you have to show the real for primary key like this way by using. So that is the way you can map. Here you can understand why we are doing like this way. These are what some other attribute, right? First name, middle name, last name related to dependent name. So then this is the way you can map weak entities. So mapping a binary relationship. How we can, so binary means two relationship can be what kind of thing? One to many, right? Or many to many. So here, one to many binary relationships. So these are very simple, right? No complex things are there. And again, as I mentioned them here, one to many, here one, okay, then here many, one customer can submit many orders. Hope you can understand this notation, this different notation here. Don't worry about the notation, and you can understand here the number of fields and the field names. That means attribute names of customer and attributes of order entities. So two entities can be seen here, right? The previously we mentioned that this is one to many relationships. If this one is one to many relationship, so what is the way the customer can have these fields? Then that fields can be displayed as this way, and customers primary key can be displayed here, and the other entity you can mention other entities primary key there, and order date there. Okay, to build the relationship, this one foreign, this one can be mentioned as foreign key, right? So that's the way. Got that? So you have to be careful when it is optional what you should do, like this way. Okay, if it is not optional, you don't need to show as this kind of dotted line. So they are the things you have to be careful. And after that, so binary many-to-many relationships, right? So many-to-many relationships, again display like this way, binary many-to-many relationships. So employee many-to-many relationships, they completed there. Then many-to-many relationships, we know that when we are displaying this in ER diagram, composite entity we should use. Got that? When you are properly displaying. And so here in this given example, employee can have three attributes here, and cause also having two attributes. Okay. Then after that, since it is producing a composite attribute there, you can build new attribute there, but then certification or other kind of certificates kind of new composite entity there. Okay, after that, so newly build that entity should have what kind of keys. Then foreign key should be inserted of relevant entities. The employee ID and course ID should be inserted there. Then other related fields can be inserted like this way. After that, foreign keys, then foreign keys should be mapped like this way, right? So this is a foreign key, course ID should be showed the primary key in real relation. Got that? So that's the way you have to deal with many to many scenario. That means when there is composite entity. Okay, just take 1-2 minutes and understand these concepts. So this relational mapping relational schema section also very important, like mapping ER diagram. Here we are discussing about map how to map relational schema with the help of ER diagram. binary one-to-one relationships, then you can understand these things now. Okay, then one-to-one relationship, these are the things you should know regarding to one-to-one. Okay, after going through these things, we can discuss the given example. Here, given example. So this is a ER diagram and nurse entity and card center entity, and there's data assigned. That means a relationship can be seen here. So here we are discussing about one-to-one relationship, and you can display that in this way. So this is related to nurses attributes, and here since this one is one-to-one, and other thing optional side and mandatory side, both different side are there. Okay, you can see here this side is mandatory and this side is optional, and that can be displayed as this way. Date assigned option can be seen here, nurse in charge. Okay, then there are the ways you can build a relational schemas. So when you are considering it whole ER diagram, you have to draw, you have to what? Mention all the required relations there, and you have to map them properly. So they are the things you should learn regarding to relational schema. We have covered this section now. So this is a sample relational schema. Now you can try to draw or map a relational schema related to this diagram, right? I will give 5 minutes. Then you can try to. After that, we can move to next new section. Multi-value attributes are there. You have to be careful. And optional relationships are there. You have to be careful. Some relationships are having attributes, they also should be careful while you are trying to map these, okay, then things into relational schema. Then first of all, you should draw, then this is a given ER diagram. You already have an ER diagram. Then next step, you can map relational schema.
The next one is about database tables and normalization. And here, so database tables you have to focus on and normalization. So first of all, you should understand why normalization is needed and what are the types of normalizations we have to study in this program, in this course, right? A normalization works through series of stages called normal forms. And first three stages are described as first normal form and second normal form and third normal form. From a structural point of view, a second normal form is better than first normal form and third normal form is better than second normal forms. So we are normally considering as consistencies, data integrity of databases. So that can be improved by normalization. That is why normalization is important. Got that? So higher normalization stages, we can consider here third normalization form is higher than to second normalization form, first normalization form. So this is the primary one. Then there is zero normalization form means zero normal form. So there are the things you can understand here. So here again, discussing about need for normalization. So now general things, okay, by going through these things, you can understand easily these facts, right? In fields of some specific table, so like these things. Read these things. This is a business application, simple scenario example. Then we can, by understanding this example, then you can understand need and importance of normalization. So you can, by going through these examples, then in example, you can understand the requirement of normalization. Here the table, and see here some so project numbers in this record. Okay, then some project names are not available, right? So normally we are then here, then these records should be completed. So this is not, we can consider as this is not a normalized one. And here the total charge is the product is hours, then read these things. So this is not containing requirements we discussed in relational database model. And we previously mentioned that, right? Okay, then by looking at this, we can just understand, okay, these things are under this project number. But here, understand here, so if the project number is so not available or the same number, then should be a problem, right? So here in this record, so there should be a primary key. Got that? So then if there is not, it is not, we have like all that kind of composite key. So if primary key or other composite key is not available, so there is a problem, right? So then so it contains as null. Got that? Then table displays data redundancies. So hope you can understand these basic facts regarding on tables. So other examples. So example, table entries invite data inconsistencies here. So the class value electronic engineer might be entered as elect engineer in some cases. So that is inconsistencies we mentioned. It is as well an electronic. So job class here, these things you can see differences regarding to job class. Update anomalies. So due to these kind of entries are different. So when the entries are different, so update anomalies would be occurred. Got that? So other updation anomalies can be occurred due to different here inconsistencies of keys. So employee number 105 when it is trying to updating. So what would be the problem? So different 105 employee records are there. Then then it would not be update records clearly, right? Then updation anomalies would be occurred there. So like kind that way, when it is inserting the records or data into tables, so the insertion anomalies would be occurred, right? Then here deletion anomalies also occurred when you are targeting to delete record by using employee number. Then unwanted data records also would be affected due to that deletion. So all these problems, all these anomalies are happening due to the informality of this database, right? Or informality of these tables. So we have to avoid such kind of problems, we have to normalize these databases. So these are some example data anomalies, right? Again, furthermore examples. So just read these things and understand these are anomalies. So conversion data into first normal form, right? So conversion to a first normal form, the data. So look at this way. So this project entries reproduce figure 20.3. So relation table must not contain repeating groups. So these are the characteristics should be follow when you are converting some table into first normal form. So not repeating groups should be there. If repeating groups are existing, they must be eliminated by making sure that each row defines single entity, right? And the process is simple. Just add appreciate entry in at least primary key columns. Yes, and the tabulate depicted figure 2.20.2 must be changed to layout shown in figure 20.4. Then this one, look at this one. So now these kind of problems are not available here. Then you can't notice that kind of previous problems. So here project number is not behaving like primary key, right? Primary key, because the project number does not unique identify. So here project number value 15 can't identify any more 5 employees are there. Then you can understand here this is not behave as primary key. Then maintain proper primary key that will uniquely identify attribute value. The new key must be combining project number and employee number. No problem. Got that? So if it is using 2 keys, then you can use that is called as composite key. So type of primary key, but can combined keys can be used for uniquely identifying records. Okay, then here, then dependencies. Here you can see that a project number and employee number. And this dependency diagram, previously we learned about dependencies, full functional dependencies and partial dependencies. Okay, we have to talk about these things furthermore. Here, partial dependencies, transitive dependencies, types of dependencies. So understanding about these dependencies would be very important when you are going or study further about normalization. So partial dependencies, transitive dependencies, and that kind of things. Here, we already know now about partial dependencies. You need to know about that project number, determine project number, determine project name. Project name is dependent only one part of primary key. And you need to know about project number to find employee name and job class and charge hour. Dependency is based on the composite primary key are called as partial dependencies here. So you know that employee name, job class, charge hour and charge per hour. So depend on what? Employee number. And here the project name is depending on project number. So, but this is a what? When it is composite key, then you can see here, then they are what? Not fully dependent of one key, then because of due to these partial dependencies. So that kind of scenarios, so by going through that kind of scenarios, you can clearly understand what is partial dependencies, what are partial dependencies. Here dependency is based on only part of composite primary key. There is dependencies, but there is composite key. So part of composite key, it has been dependent. Got that? Other things, okay. So then that kind of things are called as partial dependencies, right? The transitive dependencies are there. So here, this is explaining about transitive dependencies. As you examine 20.5, note that. So this charge hour depend on job class. Got that? Then charge hour depend on job class, and charge hour or actually job class is a prime attribute. That is what neither attribute of at least part of key. That means previously mentioned keys. Here, look at this one, charge hour, job class. Here transitive dependency because of why. So this is a job class is not a what part of a primary key, but it is a different key, and charge hour depend on job class. So that kind of so that means every then job class for an engineer, for an example, for engineer, for doctor, so of some organization, they may have some specific charge hour. For a specific job class can have a specific charge per hour. Got that? So that charge hour depends on the job class. Got that? Here the dependencies. Got that? Here this is a transitive dependency. Got that? Here partial dependencies can be observed there. So here other dependencies. Here these things are. So hope you can understand these basic concepts regarding to dependencies, partial dependencies, transitive dependencies, kind of thing. So this is just a introduction to dependencies, and we have to explain these dependencies and normalization related concepts in next session, right? So next session we have to describe furthermore these things, how you can convert them into first normal form. We already discussed, but okay, then other things, second normal form, third normal form, then after that voice code normal form, we have to discuss in upcoming sessions, right? So there are the things we have to cover for this session or this day school, okay? And